In the second part of the lecture, I'm going to talk about what exactly we mean by physical geology. Why do we have this physical part in here? So you might think about what physical means. It's the interaction between matter, between objects, and it's the way in which energy causes that matter, those objects, to change. And really, when it comes down to it, what we've realized is that geologic processes are just manifestations of physical processes, relatively simple physical laws, things like, gravity, or electromagnetism, which you can think of, charge, or even the more colloquial descriptions of these, like what goes up must come down. There's a reason for these things, right? They're very relatively simple physical laws, where opposites attract here. And it turns out that these physical laws and their interaction with the different things that we've got on Earth's surface are going to shape our entire landscapes. It tells us why we might have the Grand Teton Mountains here. And it tells us why some of these valleys are sort of U-shaped and relatively curved as they continue down slope. Whereas as you get down here, these are more V-shaped valleys. It can tell us why you've got mountains here and a really flat plain here. It can tell us why there's a river right here and what that river does to the surface around it. So just to start to give you a sense of what some of these physical processes are, I certainly don't expect you to know or remember all of these at this point, or to really know all of these in a quantitative sense by the end of the course. But I do want you to think about how these physical processes are affecting everything that we talk about. So gravity is a big one. Gravity changes how sedimentary rocks and the sediments that make them up transport down slope and settle where they do. Gravity certainly affects hydrology, things like the rain and why you can evaporate rain and then precipitate it somewhere else, and why precipitation falls downward. It affects glaciers and how those move across the landscape. Gravity also affects this other process called convection, which is the way in which the heat engine inside Earth causes changes at Earth's surface. The process of convection more generally, we'll talk about it in a little bit, but basically it means that less dense things rise. And why is that? Because gravity is pulling on them, and the forces that are exerted due to gravity are going to affect the less dense things in a different way than it affects more dense things. And as a result, you get circulation that happens. And that's going to affect plate tectonics, volcanoes, earthquakes. Other things that you might be less familiar with in gravity are things like electric charge and these weird principles of quantum mechanics. Those are what drives a lot of things on really microscopic scales on Earth's surface. Electric charge, like we said before, opposites attract. Plus charges and minus charges attract in a certain way, and that's going to govern which minerals form and how they form at Earth's surface. And it's also going to govern things like how those minerals precipitate sedimentary rocks. So you've got these dissolved ions, like when you go to the beach, you realize that the ocean is salty. Those salts can precipitate as new minerals because the ions that make up those dissolved salts attract to one another. A combination of electric charge and learning about quantum mechanics, which we're really not going to do in here, except to understand that really underlies the formation of chemical bonds, the way that atoms connect to one another. So that's definitely going to affect how minerals form. And it's also going to affect the properties of volcanoes based on the minerals and the composition of atoms that make up the liquid rock, the magma that's feeding those volcanoes. Quantum mechanics also leads us to understand a lot about geologic time, because it makes these isotopes in rocks sort of act like clocks that we can read back and figure out just how old rocks are and just how old Earth is, and come up with a number that's about 4.56 billion giga years old. Other forces matter too, and really, if you take other physics courses, you might come to realize that effects of friction or drag or pushes and pulls are really just manifestations of the forces that we've already talked about, gravity and electromagnetism. At any rate, Things like friction and drag and pushes and pulls are going to affect how sediments form, how rocks get metamorphosed or squished together as a result of plate tectonics, how those plate tectonic forces result in earthquakes, like we've already talked about in terms of natural disasters, how they affect hydrology, glaciers, and deserts and the landforms that develop in those different places. Related physical processes like temperature and the concept of heat energy being transferred, and how that affects the changes of state of matter. So at some point you learned about how matter is solid, liquids, and gases, are going to affect a host of other processes. So igneous rocks form because liquid rock turns into solid rock. Metamorphic rocks, the minerals in them change because of the effect of heat in part. Volcanoes, clearly driven by liquid rock and solid rock and the interplay between those. Glaciers, this is solid water and its interaction and the way that it forms from liquid water or gaseous water. So that's going to drive the glaciers or the cryosphere. And definitely it's going to control our climate and the way in which, because of the movement of water vapor around Earth's surface, and the changes of phase, how that contributes to where it's warm, where it's cold, and things like that. You'll note that I haven't noted everything. We could probably, take something like this and point to every single thing on here in some way. I'm not pointing out all of those. I'm just highlighting a few of them here. So just note that. The concept of rates is really important. It's not so much a physical process as it is sort of this mathematical description of how everything works. Some things happen fast and some things happen slow. And that's going to be really important to our understanding of igneous rocks, plate tectonics and the rate at which plates move, volcanoes, earthquakes, geologic time, certainly understanding how fast and how slow some processes are, and climate and how climate gets affected by natural processes and human processes. Lastly, I'll mention the principle of uniformitarianism. Basically, what this means, and we'll discuss this a little more later, is that the present is the key, I'm gonna draw a little key here, to the past. That is to say, the things that are happening on Earth's surface, the processes that happen today, are the same processes that happened way back in the past. Physics has not changed, as far as we can tell, over Earth's history. Gravity still works the same way. Electromagnetism still works the same way. Heat and temperature still work the same way. And that means that we can study what's going on Earth's surface to understand Earth's past. And so that's going to affect absolutely everything in geology. So when you put all that together, we get a big mess. And we don't have to understand all of this mess by the end of the course, but we are going to look at a lot of these different arrows in particular and learn to appreciate how physics and physical processes really affect geology in general. That's why we're calling this physical geology. We've got other courses at Pellissippi called historical geology that really focuses more on Earth's history and learning about that, and environmental geology, learning about changes going on Earth's surface right now. But we in here are going to focus on the physical aspect. We'll touch on each of these other two a little bit because they're all totally interrelated, but just know that this is what we're focusing on in this course.